Hey everyone, my name is Ben Ward, and today I wanted to show you how to make an additive oscillator in Max MSP using the Gen tool. So this right here is going to be the final product that we're going to try and make. Basically, if you're not sure what additive oscillators do, it allows you to create a waveform based off the harmonics of a fundamental frequency. So showing you with this example right here, this will allow us to control the fundamental, and then using the sliders, we can control the amplitude of each next harmonic. So this is the fundamental, second harmonic, third, fourth, and then over here you can see how that changes the waveform. 5, 6. As you can hear, each frequency gets higher. And yeah, so you can use that to craft your own waveforms and just kind of play around with additive synthesis. So yeah, let's get started. So the first thing we want to do is I'm just going to make a simple kind of a sine wave patch basically. So I'm just going to grab a cycle tilde. That's going to make a sine wave. Left inlet will be the frequency. So I'm going to grab a live dot dial. That'll make that. And then over here, what we can do is these are called prototypes. If you click this left arrow, we can go to prototypes. And then down here, I'm going to click on frequency. And that's just going to automatically give us a heading, units, and a proper range for this dial, so we can easily work with frequency values. So we're going to plug that into cycle. Then I'm just going to grab a live dot gain so we can control the output. There we go. You can already see that working. And I'll grab an easy DAC. Now we'll plug the output of that into there, and we should hear, except we don't. There we go. And now we have a sine wave. Perfect. So the next step is basically now we're going to want a certain amount more sine waves based on however many harmonics we want for this. Now in the example I had earlier, I did 32, so I'm just going to stick with that. But basically now we're going to want 32 different sine waves, each related to the frequency of our fundamental dial right here. And then we also want a way to control the amplitudes of all of those. So to move forward with that, I'm just going to grab ourselves the GUI object that we're going to use, and we're going to use something called multi-slider. So when you open this up, you can see right now we only have one slider, but if you click on that, go into the inspector, and change the number of sliders to 32 or so. Now we have some more sliders. You can see all that there. Move your mouse around. Perfect. Now the next thing we want to do is we want to start getting the gen object involved. And basically I'm going to try and replace the cycle object with a simple gen object that's going to produce a sine wave just like cycle did. So I'm going to type in gen tilde. That'll make that. And then if we double click on this, this will open up the gen patcher. So if you're unfamiliar with gen, it looks a lot and behaves a lot like Max. However, it is a bit different. In Gen, all audio processes are done on single block samples versus in Max MSP, things are done in block samples the size of your vector size here. But basically, single block processing allows you to do different things, specifically single sample delays and some car plus strong algorithms that you wouldn't be able to do in regular Max MSP. So it's really useful for doing things like that. It's also a bit faster because it is native audio processing, so it's really useful if you want to do some more advanced audio stuff. But anyways, we're not going to do anything too advanced today. Right now, we're just going to replace the sine object we had earlier. So what I'm going to do is I'm going to type in cycle. That's the same as our cycle object out here. You will notice that there's no tilde sign after it, and that's because everything in gen is already at audio rate. So there's no need to type in tilde or any of the other differentiations in regular Max MSP. In gen, everything is done. Everything is an audio process, and it's processing on those single block samples. So anyways, I'm just going to put our first inlet into that. That'll send whatever we plug into here out of that inlet, and then I'll send the output of that to out. So now we have a simple cycle thing, and I should be able to replace that. And perfect. There we go. Now we got gen set up. And cool. The next thing we're going to want to do with our gen object is convert it into an MC gen object. Now, if you're unfamiliar with what MC is, it basically stands for multi-channel, and it allows you to have multiple lines of audio running through a single line. So I'll show you kind of what that looks like. If you go over to your gen and just type MC dot, boom, now we have an MC.gen object. And if you hover over what's now the blue cable, you can actually see the audio processes and the number 1. That'll tell you how many channels of audio is running through that cable. So right now we only have 1. But I'm going to go over here and type in @chans32, and that's going to specify that we want 32 channels of audio coming out of this MC gen. So now if we hover over that, boom, 32, and you can see we have 32 of the same signal being duplicated. But we're going to change that, because what we want is we want each one of those 32 channels to have a different frequency, all relative to our fundamental frequency. And the way we're going to do that is if we go into our MC gen object, we can actually obtain the channel number from the MC gen system by typing in MC underscore, there we go, channel. And that will tell us, that'll basically get the channel number of whichever channel is currently being run through that, and then you can use that for processing. And what we're going to do with that is we're going to get a multiply object, put it in front of, or put it before the cycle object, and then just multiply that incoming frequency with the channel number. So that'll automatically adjust all the frequencies for these audio signals to be the relative harmonic that we want for that channel, which is perfect. So we'll do that. And then I'm going to grab another second inlet here. Grab another multiply. Perfect. And that's going to allow us to control the amplitude of each one of those channels of audio. But cool. And that's pretty much it for MC Gen. That's all we will need for it. The rest of the processing we're going to need to do is going to be setting up the data coming from this so that it's properly, set up properly for the MC Gen object. But one quick thing we want to do before we do that is when you have an MC Gen object like this, because you have 32 channels, you need a way to mix them together or at least separate them so you can listen to them. But what we're going to use is we're going to use the mixdown object. So this is called MC mixdown. And this is really useful if you ever have multi-channel signals. Basically, you put that in there, specify how many channels you want it to be summed into. We're just going to want 1. And that'll automatically add your signals together and then divide them by how many signals you had to get them in the same range. So you see now we have 1 signal, and if we turn this up, we won't hear anything yet because we need some amplitude data, but that's pretty much how that's going to work. So the next step is going to be to prepare the data from the multi-slider object. So looking ahead, the way we're going to send data into MC Gen is using the line object, and actually we're going to be using multi-channel line, so just type in MC dot before that. We'll need to specify the channels at chans32, and perfect. And basically what we want is we're going to want to create a line so that whenever these change, it creates a new line with a given duration, and that will change all of the channels of audio that we have here based off the amplitudes that we send out of this. So I'm going to plug that right into there. But now we need to start preparing the data coming out of this. So let's see what that's showing us at the moment. If we print that out and look in the Max console, we can see that every time we change this, it outputs one list message that contains every value of each of these sliders. But we're going to need to change that so that we have individual messages for each one of these that is sent to the MC line object. So the way we're going to break this up is we're going to use an object called iter. That is going to simply iterate a list message that's sent into it. So if we print that out now, you can see every time it changes, first the list is broken down into individual messages, and then all of those are sent in order. And now using that, basically we're going to need to attach a number to each one of these, or an index to them, so that when we send it to the line object, we know which channel we want to change the amplitude of. So what I'm going to do is I'm going to grab a counter, use the arguments 1 and 32 to give us the range that we'll need. And then I'm going to grab what's called a trigger object. And this allows you to type in commands that are set off every time something comes into the inlet. So I'm going to type in T for trigger, F for float, and B for bang. And so whenever one of these messages comes through, first it will send a bang out, bang the counter. Then we are going to pack that together using a float and an int. We're going to pack the index that comes from the counter with the value that we received from the table. So that will combine those two together, and let's just print that to take a look, make sure we're getting what we expect. If you do that, perfect. If you see over here, now we have all those values in order, but they're coming through in a list with an index at the end from 1 to 32. However, we're going to want that index to be in the front. So the way that we can change that is we can grab a zl.rot object, ROT stands for rotate. And that'll allow you to basically what's called rotate a list, which just means shift values to the right or left. And since we only have 2 lists, we'll just type in 1. That'll shift everything once. And now if we do that, perfect. We still have all our float values, but this time the index is in the front of that. And now basically all we need to do is for the line object, it's going to want a message called set value. So we're going to get that. Then we're going to type in the arguments 1, 2, and 3. And these are going to stand for basically the first inlet will be the index, second one will be the float value, and the third one is going to be the time. And that's going to let MC line know when it's going to this next second value we specified here. This will decide how long it takes to get there. And that's just useful because if we change this, we may want it to be a slower, a gradual change to the new values instead of just being instant jumps, because that can sound a little harsh. But we are going to need a message for that. So what I'm going to do here, is get a pack. We'll need int float and float. And it's a little annoying, but we will unpack this. And then we're going to get another live.dial. Go to the prototypes. This one is going to be time. Now we have a time dial. And I'm just going to plug that into the furthest right inlet, put that in the middle, and boom. Now let's just make sure that we're getting what we expect with that. Turn up the time dial, and then perfect. So this time value is going to apply to all of the channels. It's going to be a global value. You probably could make a way so that the time value applies individually to each harmonic, but that seems a little bit unnecessary, at least for this project. But anyways, that's looking good. So now we're just going to plug that into the MC line object, and hopefully we should hear something. Oh, if I turn this up. No. Okay, let's see if line has an output. It doesn't. So what are we missing? Okay, so I figured out the problem. It had to do with something with the unpacking and packing. So I'm just going to delete that. Grab another pack object. This time we're not even going to unpack it from the ZL rotate. I'm just going to put it in there. Second value should automatically fill this float value. And let's see if that gives us the values. Oh, yes it does, as we just heard. So now that's working. And let's just make sure that the time value matters. If I make that a second, perfect, yeah, you can hear that it takes about a second for everything to get to the new value. If I close it all, awesome. Now one thing you may notice is that these values up here in the multi-slider, when you're changing them, they will not update until you let go of this. Basically, if I change all this, you can hear that I won't do anything yet until I let go of the mouse. But you can actually change that behavior. So if you click on the multi-slider, go into the expector, there will be a value you can enable called continuous data output when mousing. If you click on that, then whenever you change these values, they'll automatically update, which is perfect. So that's the bulk of the patch. If you're just looking to try out additive oscillators and kind of see how they work, then this is really all you need. But then to make it like the example I showed at the beginning, I'm just going to add a couple extra little features you can have in case you wanted to make this more of a instrument or device for music making or anything else. So I'm going to add a random value generator that whenever you click on it, it will produce random values for the multi-slider for all of the harmonics. So to get started with that, actually I'll just leave that there. I'm just going to get a bang that'll trigger when we want this to happen. Make it a little bigger. And then I'm going to grab a rand object, and that's going to create, or a random object, and that'll create value between 0 and whatever your argument is. So we want it between 0 and 100. And then we're going to divide that by 100. That way we have it in the range of 0 to 1, because that's the range of our multi-slider values. But so we're going to grab the bang. The only thing is, we don't just want one random object, we're going to need 32 of those. So what you can use is an object called Uzi. And if you give that an argument of 32, basically when you bang that, the left outlet will send your argument number of bangs to the next object. So when you click that, you don't just get one bang, we're going to get 32 of those. And let's just print to make sure that works. Perfect. 32 random values between 0 and 1. But now we want to grab all those values and pack them together so we can send it to the multi-slider. So I'm going to grab an object called ZLStream, give that an argument of 32. This is the opposite actually of our iterate object. Instead of breaking down lists, this is actually going to group individual messages into a list. But you need to specify an argument so that way it knows when to repeat. We're going to do 32, and now if we print that, we should see instead of 32 messages, just 1. Perfect. 32 messages, or 32 values in one list message. So actually now what we can do is we can put that right into the multi-slider object, click bang, boom, 32 random values, just like that. If you keep clicking it, you see it keeps working. However, I do notice that we're getting values between 0 and 1, and that this multi-slider is actually going to -1. So I'm just going to change that really quick because we do want that to be between 0 and 1. Perfect. Now, awesome. Now we're getting the full range. However, I don't think that works yet. Let's see. Oh, it does. Perfect. So that's all we need. We can change the time. Awesome. Cool, so that's pretty much it. Now the very last thing I'm going to do is I'm just going to put this into presentation mode, clean it up a little bit. That way we have a little bit of an interface to work with in case we want to show this to someone else and want to let them play around with it. So I'm just going to grab all the GUI objects we'll want. Hold Command-Shift-P. That will add those to the presentation view. And then just to give it a little background, I'm going to grab a panel object that doesn't do anything. I just use it for kind of design purposes. but you can click that, change the color. I'm going to click include in background. That just sends it behind every other object. We'll make that bigger. Actually, I'm going to make this white. And then give it a little bit of a border. Perfect. Put our frequency dial, the time dial, output. This will be our random dial, and this will be our main multi-slider. So we'll do something like that. When we get a comment, just give it a title. Perfect. There we go. Now we have ourselves a little basic looking synthesizer, additive synthesizer. It's cool to play around with. You can make new waveforms. And actually, that reminds me, there's one last thing we should add to this patch. And that is going to be a scope so that we can actually see the waveform that we're creating. So if you type in scope, that creates that. Then we're just going to grab the output from MC Mixdown. Then you can see that. I'll just move it down here. Then I also like to grab one of these, which is useful for altering the display depending on the frequency of the main dial. So if we change that, then we can use this to kind of fix it. Cool. Okay, so I just played around with that for a bit so I could get good values. This is kind of hard to control, and it does depend on the frequency. But once you do get it in the right spot, it's cool to then use that. Actually, I'm going to add this to the presentation. And then once we're back over here, you can see that when we change these, it's a good way to view how these changes in the multi-slider are going to affect the actual waveform. So yeah, there we go. This is our final product. Obviously, it's not the cleanest, but if you're doing this on your own, you can clean it up, make it look how you want. It's also really easy to just throw this into a Max for Live device. So if you do have Live Suite, there you go. This is a free additive oscillator you can add to your library of sounds. But yeah, that's pretty much it. I hope you enjoyed this tutorial. If you found this helpful, feel free to leave a comment or a like. And I'd love to hear some suggestions if you have any for future videos. And yeah, thanks a lot.